Here's going to be the worked out solution for the 11.5 problem number 3. First of all, in order to inscribe a circle inside of a triangle, you have to know that the center of that circle, which in this case is point D, is the in-center of the original triangle, which means that if I were to draw in this segment AD, it would be an angle bisector. If I were to draw in that perpendicular, the length of GD is equal to the length of DH is also equal to the length of DE. I know all of that, and because these are tangent segments going around the circle, then I also know that AG is equal to AH, and so forth. To start finding some of the lengths that we're going to need, let's start with a walk-around problem. This length is x, this is x, 10 minus x, 10 minus x. This is 18 minus x, 18 minus x. And then together, these two segments, the 10 minus x and the 18 minus x, are going to sum up to 28 minus 2x. That's equal to the given length of 16. 12 is equal to 2x, so x equals 6. That allows us to find out all of the different sides going around the triangle. If x is 6, that means that this length is 12, as is this length. And those are going to be the most important ones for us, so I could plug in the other ones, but we'll just stay with that for right now. Next, on the entire triangle, clear some of this stuff out. The entire triangle is a side-side-side case where we have 10, 16, and 18. So we can use the law of cosines to find this big angle over here on the side. In other words, 10 squared equals 16 squared plus 18 squared minus 2 times 16 times 18 times the cosine of that big angle A. And then when you solve for this angle, the measure of angle A is approximately 33.6 degrees, and we're going to store this as A on the calculator. Then looking at this triangle, triangle GDA, we know that it is a right triangle. We know that this length is equal to 12, and since this entire angle is the about 33.6, we can take half of that angle to get this little one that we need. In other words, we're going to look at this triangle, GDA, and we know this is 12, and then this angle, this acute angle, is going to be half of angle A. To figure out GD, which is the radius of that circle, which is going to be important for us, we're going to say that the tangent of, let's call that angle theta, is equal to GD divided by 12, and multiply both sides by 12, so 12 times the tangent of theta, theta we know, is equal to GD. So then, doing those calculations, we get that the length of GD, or the radius of that circle, is approximately 3.62. So we've got a lot of important numbers in here so far, and we'll minimize some of this. And then, to get that shaded area, write this down specifically then, the area shaded is equal to, there's a few ways you could calculate it. I see it as the area of that kite GDHA, minus the area of this sector that's just in that area right there. There's a few ways to find the area of a kite. We could find the area of this triangle and double it. We could do 1/2 diagonal 1 times diagonal 2. As I see this one, I already have enough information to find the area of that triangle. So the area of the kite then is 2 times 1/2 the base of 12 times the height of, which is the radius of that circle. And this will give me the area of that kite. It gives me the area of the triangle, I double it, it's the area of the kite. So the 2 and the 1/2 cancel out. So the area of the kite is 12 times the radius of the circle. Now we have to subtract away the area of this little sector. So what we know about that sector is that there is a central angle. We don't know that yet, but that's going to be divided by 360 times pi times the radius, which we already know, squared. So in order to finish off these calculations, the last thing we have to really find is the measurement of that angle. And to do that, we look at the fact that we have two tangents intersecting outside of the circle. If I call this x degrees and this y degrees, I can come up with a couple of equations. First of all, y plus x equals 360. I know that because together they're going to make up the entire circle. And then the other thing I know is that y minus x divided by 2 is equal to this angle on the outside, measure of angle A. Again, which I already have stored into the calculator. So if I look at this second equation, I can double everything to make it look a little bit better. It becomes y minus x equals 2a. The top equation we'll just keep as y plus x equals 360. Adding those equations together, 2y is equal to 2a plus 360. So then divide everything by 2, y equals a plus 180. We can solve for y. Once we know y, we can subtract that from 360 to get x.
Honestly, I'm looking for ideally a 3-bedroom, 1.5 bath, more baths than that. Could go as small as a 2-bedroom, 2-bath. Really, I was hoping to.
So the angle y comes out to 213.6 degrees approximately, which means then if we plug that back in, x is approximately 146.4 degrees, and we'll store that as alpha x.
Oh, there are other methods. Are there quite a few young children in there?
Put that into this formula, so we already have the area of the kite minus x over 360 times pi times b squared. Now it's just a matter of going through the calculator. So then plugging that all into the calculator, you get a shaded area of approximately 26.69 units squared.